Okay, I'm going to start Unit 2 review. Number 1, describe the translations. Again, this is very similar to what we've done before. This is going to go up 4. This one is going to go to the right 3. And this one will go to the left 2, down 1. All right, number 4. Write an equation in vertex form. So that's going to be y equals, assume a is 1, so we don't have to worry about parentheses. It's going to be x. It's moving to the right 2, so that's going to be opposite of what we think, and up 3. And now we're going to write the same equation in the standard form. So we're going to have to multiply x minus 2 times x minus 2. And we will get x squared minus 2x plus 4. We'll put these together and we'll get x squared minus 4x plus 4. And the last thing we have to do, oops, I didn't set it, but I didn't write it. We have to add a 3. So we're going to actually add 3 to 4 and get 7. So our equation will be letter D. Excuse me. Number 5, identify the vertex and axis of symmetry. These are so easy. All right, x misbehaves, so that's 2, 3. X equals 2. The vertex is at negative 3, 2. X equals negative 3. Vertex is at negative 4, negative 1. The axis of symmetry is x equals negative 4. All right, not so easy, this one. We got to work for this one. Negative b over 2a. So the opposite of negative 8 is positive 8. 2 times 1 is 2, so that's equal to 4. That's actually our axis of symmetry, so we'll start there. And it's the first piece of the ordered pair for the vertex. To find the partner, I'm going to run the 4 through this equation. And I'm going to get 16 minus 32, which is negative 16. Negative 16 plus 19 is positive 3. The y-intercept is always the value of c. So c is 19. The domain is always all real numbers for a parabola. Okay, the same thing here. Vertex is negative, or the opposite of b, which is 4, over 2 times negative 2, which is negative 4. Sorry, that should be a positive. The opposite of negative 4 is positive 4. 2 times negative 2 is negative 4, so that's negative 1. That is the first piece of the axis of symmetry. Remember, you do have to have this x equals. All right, it's also that. Now I'm going to plug the negative 1 in for both of these x's. Come with me. Negative 1 squared is 1 times negative 2 is negative 2. Minus 4 times negative 1 is positive 4 plus 6. So that's going to be equal 8. Okay? And the y-intercept is 6, and the domain is all real numbers. I wonder if I left off the range here. Did it get cut off? Yeah, it did. It did. It got cut off. So let's talk about the range. Let's go back to question number 8. The range is the y value, and this is going up. So you might want to draw a picture. This is a parabola that is going up because it's A is positive. The lowest point of here is 4, 3. So the y values are going to be more than 3 or more. So it's going to be y is greater than or equal to 3. Over here, this parabola is going down. So the maximum point here is negative 1, 8. So the highest point here is at 8. And it's everything less than that. So it's y is less than or equal to 8. All right, looks like we had to sketch that. I wonder if it's on the next page. Oh dear. That whole thing is on the next page. All right. I should have done it on this page, folks. So the vertex, let me go back and look. Vertex is at 4, 3. So I'm going to plot the point at 4, 1, 2, 3, 4, 1, 2, 3. And it has pattern points of over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3. And I want to go off the patch of graph paper, so I'm going to see if I can go over 1, up 5, over 1, 1, 2, 3, 4, almost. I'll improvise. And then I'm just going to sketch it, just like that. The next one, the vertex, let me go back. Sorry, I gotta go back. The vertex was at negative 1, 8. Okay, so at negative 1, 8, it's right there. Has a y-intercept at 6, that's non-negotiable, and it also satisfies the pattern points. The a is negative 2, so we're going to multiply this odd number pattern by negative 2. So we're going to get 1 times negative 2, 3 times negative 2, 5 times negative 2. And these are our drops. So it's over 1, down 2, and the reflection point. Over 1, down 1, 2, 3, 4, 5, 6, and the reflection point. The next one would be over 1 and down 10, so that's 1, 2. Right there. And then reflection point. This is a nice thin graph. Parabola. Oh, that, my gosh, I gotta do that again. Oh my gosh. All right, folks, this is the comedy hour. Let me see if I can do this. This is what you get when you do things live. When I make these ahead of time, you don't get the commentary. All right, there you go. There you go. Let's move on. Oh, no, not, is this, wait a minute, is this the same one? Hang on. 9. Yeah, that sure is the same one. Okay, I'm not doing it twice. Okay, this one, am I going to be able to do this one without a calculator? Yeah, I think I need a calculator for this one, and I don't have it. So you're actually, let me just walk you through this one. You're wanting to maximize the profit, so you have to find the vertex. This is in standard form, so you're going to take negative b over 2a. And then you're going to run that number through this equation with your calculator to get the y value, because it's the y value that answers this part, the y value of the vertex. Oh, wait a minute, I read that wrong. What will the maximum profit be? That's this right here. That's the y value. This says how many. This is number of DVDs. This is the x value. So let me fix this. This is your x value of your vertex, and this is your y value of your vertex. Okay, have fun with that. All right, let's move on. Oh, I might need some help with this one too. We'll see. So let me just say that none of this is going to play into this because they already give us the equation. The y-intercept is at 20, and this is marked off by 4, so I know that it's going through that point. I can probably do negative b over 2a here, so it's negative 32 over negative 32. That's negative b over 2a, folks. So that's 1. I'm going to run the 1 through this equation. I'm going to get negative 16 plus 32, which is 16. And 16 plus 20 is 36. So that's the vertex. 1, 36. It's way up here. Okay? And you can do your little reflection point. Don't use pattern points on this one because it's not as easy. So we're going to graph this equation. And what is the maximum height? It's always the y value. Okay. Now this was on the last test and it was counted as a bonus, but it won't be on this exam. So make sure you understand how to do this. This is a system of equations. And so this is telling me that y is the same as x plus 3. So this y right here is also the same as x plus 3. So I'm going to plug in x plus 3 is the same as x squared plus 2x plus 1. Okay, so now it's a quadratic equation, and I'm not going to make you graph it. You just have to solve it algebraically. So you're going to remove this, x and 3, and set it equal to 0. And this one is perfectly set up to factor. So I can split up x squared to x and x. And really there's only one set of factors for 2 and 1. And this is where you got to get your signs in the right place. I'm trying to get a positive 1 out of this. This gives me a positive 2x. This gives me a 1x. They both can't be positive because then I'd have a 3. And I want a 1. But if I subtract them, if I subtract the 1 and add the 2, that'll give me what I need. All right, so this is equal to 0. Erase all that. 0 product property. So x is going to equal 1, and x is going to equal negative 2. Remember, you're looking for a point of intersection, so you've only found the first part of your answer. You're going to go back with that 1, and you're going to plug it into this equation and find the value of y. What's the value of y when x is 1? And the answer is 4. What's the value of y when x is negative 2? Well, negative 2 plus 3 is 1. So that's your answer. Okay, so we're going to do the same exact thing for this next one. Y is the same as negative 4x minus 9. So this y is the same as negative 4x minus 9. So negative 4x minus 9, or excuse me, plus 9 equals 6x squared plus 9x plus 4. I'm going to move 4x and my 9 by inversing them. And my new equivalent equation is 6x squared plus 13x minus 5. And that's equal to 0. All right, so let's see what we're going to do. This one's got multiple options for that 6. It can be 6x and x or 2x and 3x. But honestly, there's only one set of factors for 5. So we're going to have a 5 and a 1. We can't split 5 up any other way, just so you know. I'm going to multiply 5 times 6 to get negative 30. Factors of negative 30 that equal 13, or that subtract to equal 13, are 15 and 2. Notice if you had 10 and 3, you can't get a negative out of that because they both have to be a positive to get a positive 13. So that one got disqualified. This is going to be positive. This one's going to be negative. Okay? So this and this have to equal 15 and 2. So this has got to be 3 to get the 15. And this has got to be the 2 to get the 6x. Now let's get our signs right. This is a positive 15 and this is a 2. We want that 2 to be negative. So this is going to be negative, this is going to be positive. All right. So x is going to equal negative 5 halves. And x is going to equal 1/3. You are going to run those two numbers back into either one of these two equations. It doesn't matter which one, but hey, I'm going to go with easy. So y is equal to negative 4 times negative 5 halves plus 9. That gives me 20, positive 20 over 2, which is 10, which is 19. So one of my ordered pairs is going to be negative 5 halves 19. See, that wasn't too bad. All right, my second ordered pair, I'm going to run the number 1/3 through there. So the value of y when x is 1/3 okay, that gives me negative 4/3 plus 9. Okay, I can change that 9 out to 27 over 3 because you have to have a common denominator. And when you subtract 4, you get 23 over 3. So at 1/3, 23 over 3, and you can leave it like that or you can change it. Doesn't matter. Those are your 2 points of intersection. All right, next. Let's see. This is your adding and subtracting of imaginaries. So we're going to just drop parentheses off. And when we do, we're going to change the signs because we're distributing this negative. And then I'm just going to add negative 5 with 4. That's going to be negative 1. Ooh, where did I lost something here. No, I didn't. Let me back this up. I thought I had an extra I. We're going to add negative 5 with 3, which is negative 2, plus 4 is positive 2, plus 3i. So there's your answer. Okay, number 2, if I drop all the parentheses off, nothing is going to change because it's all addition. And I'm just going to add these two, which gives me 13, and these two, which gives me plus 3i. Okay, number 3 is actually a, a multiplication problem. So I'm going to distribute the 5, negative 5, and I'm going to get 40 minus 40i, and then I'm going to distribute the I times negative 8 is negative 8i. I times 8i is plus 8i squared. Now, some of you ding-dongs left I squared in your answer. Don't do it. Don't ever do it. Change that I squared to a negative 1. So really all it does is it changes your positive 8 to a negative 8, and now you can subtract 40, and 8, and you're going to get 32. And then you're going to combine your i's, you're going to have minus 48i, and that's your answer. All right, number 4 is pretty much the same way. 2 times negative 8 is negative 16. 2 times negative 6 is negative 12i. Now I'm going to distribute the negative 8i. It's going to give me a positive 64i and a positive 48i squared. Don't leave that I squared. Just change that to a minus. And now, you're going to subtract 48 and 16. That's going to be negative 64. And then you're going to combine these two, which is going to be plus 52i. There's your answer. Number 5, we're going to multiply by the conjugate. Conjugate of 3 plus 4i is 3 minus 4i. 3 minus 4i. I'm taking the shortcut. A squared plus b squared. Some of you ding-dongs put I in that, and you're not supposed to. You're just taking these numbers, 3 and 4, and squaring them. You always get positive numbers when you square. So 3 squared is 9 plus 4 squared is 16. Now, if you're uncomfortable with that, you just go right ahead and FOIL it out. Distribute it out. You're going to get the same exact thing. Or should, I should say. So 9 plus 16 is 25. And now I have to do the real deal with this numerator. I have to distribute negative 6 times 3 is negative 18. Negative 6 times negative 4i is plus 24i. Negative 8i times 3 is minus 24i. And plus 32i squared. This is all over 25. I lost my 24 i's. This becomes a negative 32. The top becomes a negative 18 minus 32 is negative 50 divided by 25 is negative 2. All right, I need to move that. The conjugate of 1 minus I is 1 plus I. 1 plus I. Multiply a squared plus b squared, both positive numbers. They're both 1. 1 squared plus 1 is 2. That's my denominator. And then 1 times 1 plus I is 1 plus I. Nothing you can do to reduce that. There's your answer. All right, where are we? Oh my gosh, we're at 23 minutes. Good grief. Excuse me, factor completely. GCF, baby. So take out the 2, 4x squared minus 1. The only time you can factor a 1 with 2 terms is when it's the difference between 2 perfect squares. And so that is the difference between 2 perfect squares, 2x plus 1, 2x minus 1. GCF again, let's see, is it a 4? 2? It's a 2. So we get 25n squared minus 4, and voila, the difference between 2 perfect squares. 5n plus 2, 5n minus 2. Keep the 2 in your answer. Keep this 2 in your answer. This one, does it have a GCF? Yes, it has a b. And we're left with 8b squared plus 14b plus 5. This is a trinomial. Probably should check to see if it can be factored. It looks like we can factor it into 2 binomials. 5 only has one option, 5 times 1. So you might as well put it there. A times C is 40. I'm going to move into these other problems, but I'll erase it. Factors of 40 that equal 14 are 4 and 10. Okay, so take this number and one of these numbers and take the GCF. That's going to be a 4. So I know that my first piece is 4b, which means that this has to be 2b. And I'm not sure if that 5 and 1 are in the right place. This is where I have to do this little thing. And this was just luck, folks. It worked out. 4b, 10b, both of them positive. And so our final answer for this one is going to be, told you this was going to be messy, really messy. Final answer is B times 4b plus 5 times 2b plus 1. All right, didn't mean to do that. All right, there we go. We're moving on to the next one. It also has a GCF of 4x squared. So when I divide a 4x squared out of an 8, I'm left with 2x minus 1. There's nothing more I can do. This is not the difference between two perfect squares right here. You're done. All right, number 11. Oh, I see an even number. And I see that 4, at least a 4 can come out of those. Let's see what happens when I have a 4. I'm going to have 10r squared plus 7r minus 12. Okay, looks like I can probably factor that. I'm going to multiply 10 times 12 to get 120. That equals 7. Let's see. We got 12 and 10. That's not going to work. Sorry, that's Poppy. 12 and 10. That doesn't work. Break this down into smaller pieces. Maybe 3, 4, 5, 2. I got 20 and 6. That won't do. I got 15 and 8. 15 and 8, folks. Look. 15 and 8. 15 and 8, if I subtract them, will give me a positive 7. All right, let me get rid of this mess. So I'm going to take the GCF of one of these numbers and compare it to 10. I'll take 15, so that's 5. Well, if this is supposed to be a 10, and this is 5, then this has got to be a 2 over here. Let's put those R's on there. And I got to get a 15 and a negative 8, so 5 times 3 is 15. 2 times negative 4 is 8. And don't forget this 4 here. So your final answer is this right here. Okay. All right. Next one, it looks like I can take out a 9p. I'm going to be left with p minus 6. Do an inspection. Is it the difference between two perfect squares? NO spells no. So you're done. You're done with that one. This one, does it have a GCF? Oh, no, it doesn't. I don't want to multiply 4 times 27. Let's just play around with this one. Just going to play around with it. Let's go with 2R and 2R. And again, I'm just, that was arbitrary. I could have been 4 and 1. Factors of 27 are 3 and 9, 3 and 3. Well, folks, guess what? It's not going to be let's see. It's not going to, we can't multiply anything by 2 to get a 3. So you got to put those numbers on the outside. So you got to put a 9 here and a 3 here, and you can't multiply. So guess what? 2R is not it. It's got to be 4R and 1. That's Poppy in the background. You hear him pounding his leg? All right. I'm still stuck on this one. I don't think this one could be factored. I'm gonna say this one can't be factored because I need to get a 27 here, and the only way I can get a 27 is with these three numbers, and the only three numbers I can get out of that are 9 and 3, and I can't multiply anything by unless it's 27. Nope. This one can't be factored. Now, I might be wrong. It's late. It's 9:15, past my bedtime. I may have to come back to that one. But I'm looking at it and I'm thinking, why did I put one on there that couldn't be factored? They do have that option, though, and I might have accidentally pushed it. If you find the right answer, come to me. I might have some candy or something for you. All right. This one, GCF, is definitely an N. And we're left with AN squared minus 14N plus 3. All right, I'm just going to do the 8 times 3, which is 24. Factors of 24 that equal 14, 12, and 2. Both of them negative. I'm going to take one of those numbers and compare it with the 8. Let's take 2 and 8. GCF of 2 and 8, I'm looking at this 2 and this 8, is 2. So I know that my first one's going to be 2, which by logic, this one has to be 4n. 3 only has one factor, so do I put the 3 here and the 1 here, or vice versa? We'll play around with it. We got to get a 14. That gives me 6 and 4, no cigar. So I'm going to have to switch these. Oh gosh, I didn't mean to do that. That's so large. All right. So I'm going to put the 3 here and the 1 here. This gives me 12 and 2. Both of them are minus. Voila. Don't forget, this is part of your answer, the ends. This is your final answer. All right. How many more pages? Man, we got a lot more to go, and we're at 32 minutes. I might have to stop and start a new video. Do I want to do that? Yes. I'm going to stop this video, and I'm going to finish it in a third video because this is going way too long. I don't know if YouTube will take a 32-minute video. All right, folks, it's late. I will be back because I want to get this done.